For problem number 4, we need to create a system of linear equations from the following problem situation and then solve it using any of the 3 methods we have learned in class. So I'm going to show you all 3 of them, and whichever one you picked is fine. So the first one is substitution. So if we were going to solve this using substitution, first we would read the problem. Sports ticketing company offers 2 ticket plans. One plan costs $110 plus $25 per ticket, and the other plan costs $40 per ticket. How many tickets must Gloria buy in order for the first plan to be the better buy? So now we annotate. Looks like that is important, and that's important, and we want to know which one is the better buy. Okay, so now we formulate it. We can represent this first sentence, one plan costs $110, as the amount that we pay in the plan is Y, and we pay $110 plus $25 per ticket, and we'll make the number of tickets that we buy X. The other plan, the money that we pay in the other plan is Y. We'll say that's equal to just 40x, 40 times the number of tickets. Okay, so if y equals 110 plus 25x and y also equals 40x, then these are both equal to each other. In this top equation, instead of writing y, I can write 40x. I can say 40x equals 110 plus 25x, so I can subtract 25x from both sides, and I get 15x equals 110. And if I divide both sides by 15, I get x equals, let's see, I can divide both of these by 5, and I would get 22 over 3. So this would be 22 over 3, or 7 1/3. Okay, let's see how we would get that same answer using combinations. Okay, so if you decided to use combinations, you might have done something like this. You might have written your first equation as y equals 110 plus 25x, and then your second equation as y equals 40x. And now we're trying to get one of these numbers to be the opposite of the other number. So if I multiply this bottom equation by -1, now I can have equations that look like 110 plus 25x, and I would have negative y equals negative 40x. If I add these two equations together, y minus y is 0. I have 110 minus 15x. If I add 15x to both sides, then I get 15x equals 110. Divide by 15. I get x equals 22 over 3, or 7 1/3. Okay, and our final solution method is graphing. So let's see what this looks like if we graph it. Let's start writing down the number of tickets that Gloria might start buying. She might buy 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 tickets. And we would need to see how high this graph needs to go. And the way we would do that is by plugging into our equations. Y equals 110 plus 25. Let's plug in where the point lands if we plug in 0. And let's also plug in where the point lands if we plug in 10 to see where it goes on the left and right sides of the graph. Okay, so if I plug in 0, this means I have a point at 25 times 0 is 0 plus 110 is 110. And if I plug in 10, then I get 10 times 25 is 250 plus 110 is 360. Okay, so this means I have 2 points at 0, 110, and 10, 360. Okay, now let's try the second equation. Y equals 40, and if I plug in 0, I get 0. And if I plug in 10, I get 10 times 40 is 400. So this means my graph needs to go up to 400. So if I make my graph up here 400, if I have 400 units, how many boxes do I have? 1, 2, 3, 4, 5, 6, 7, 9, 10. I have 10 boxes along the y-axis. If I divide that by 10, that means I have to count up by 40s. So this means I'm going 40, 80, 120, 160, 200, 240, 280, 320, 360. Okay, now I'm ready to start graphing. I'm going to do this in blue so it's easier to see. Okay, so I need a point at 0, 1, 10, which looks like it's about here. 0, 1, 10. I need another point at 10, 360, which is right there. Okay. I need another point at 0, 0, which is right there. And another point at 10, 400, which is up here. Okay, so now, if I draw these lines, I should find my intersection point. And if I look at where they cross right about here, which is somewhere in between 7 and 8. So my final answer would be Gloria must buy more than 7 tickets for the first plan to be the better buy. There we go.